And so with that, any questions? And while we hook up for Jonathan? Yeah, it's true. I gotta admit them all. And some of the transhuman coin holders as well. So we've got Lisa Andrews there from Wavia. Might do a quick, maybe like say hi. Like if you want to come up and say hi and do a bit of an intro if you like. Well, we set up for Jonathan as well. Lisa, did you want to go first? Yeah, speak up. Yeah. Up to you guys.
Well, welcome everyone, and thanks for coming tonight. I'm a little bit short here, so I'm just going to have to tiptoe here. But thank you so much for your continued support over the last 8 years. So 8 years ago, I helped co-found Transhumanism Australia, and it started as a small meetup group within a pub. So it was the Metro, I think, where we held one of our first meetings. It was one of the first few Sydney pubs that took Bitcoin payments. Unfortunately, it's shut down now. It's not related to Bitcoin. And 2 years ago, there was a community token launch for the transhuman community called Transhuman Coin. And so since then, we've grown transhuman coin holders to about 20,000 people. And it's really thanks to my fellow co-founders, Peter here, and also Charles Awuzie, and also our amazing community manager, Andrew, who's been with us from day one. And of course, our scientific advisory board, which includes Lisa and also Jonathan and Avinash, who are speaking tonight, and many others in this room as well. So we're really excited about continuing the progress towards transhumanism. And every day we ask ourselves, do we want to be the type of civilization who just accepts things as they are? Or do we want to be the type of civilization who reaches for the stars and also explores the potential for limitless health span? So that's what really drives us. And so I thank you for your continued support, and I hope that we get to catch up throughout the evening. Enjoy.
Come around here super quick so I can say hello to everyone online as well. Hello. I am the CEO of Wavia, but most of you may know me as the co-CEO of Singularity U Australia. I love seeing your backpack there. We've had a couple of summits here in Australia, and Peter is also international faculty for Singularity U. So it is very cool. This is my second transhumanism meetup here at Stone and Chalk, and it's nice to see the community growing and people wanting to make a difference. Does that resonate with everyone wanting to make a difference? I think this is the kind of tribe that attracts each other. So I'm here to support and love the idea of this being 1 degree of separation from anything that you need. And certainly hats off to both you and Elise for putting this together and being able to, bring this amazing community together. So thank you. And I look forward to connecting with you all, if not tonight, in future meetups.
See, Mel Ludo can't join us tonight. We've got Tristan Grace in the community there who runs over here. Yeah, there he is. And he's been building out Doppel. Do you want to say a couple of words for you as well? Yeah, of course.
Great to be here. Involved in pages. Just trying to make an AI version of myself and everyone having their own photos of themselves, and that's what I'm working at the moment. So, hey.
We don't do a proper demo. We've got also globally Dr. Natasha Wiedemore, who's one of the co-founding members of Transhumanism globally. And of course, Dr. Aubrey de Grey, who's actually been the spearhead of advocating for healthy longevity around the world. And yeah, there's Bo as well, to say hi. Jose, Dr. Jose is also part of Singularity University, and also Dr. Charles, Elise mentioned, our co-founder. So yeah, with that, there's some of the crew here. Yeah, with Stefan, there he is. Stefan, myself, Michael, and Bo have been sitting down here for the last couple of weeks. I've been doing some podcasts on the crew, so if you want to check out Transhumanism Videos, our YouTube channel, and there's some good podcasts coming through from Roy. Zoltan, you might have heard, this guy is the OG transhumanist in the US, running for president. Had a conversation with him. Transhuman Coin is really tokenizing this community and how we accelerate the startups that are working in this space. started with Bitcoin, went to Ethereum, building that network state. And so transhuman network state is actually how we can have these people, places, and laws through smart contracts enable acceleration of this transhuman community globally. So we've got 20,000 holders and counting. We've built out a lot of these selfies from people that are holding globally here in our metaverse environment. We've got an e-commerce store, basically using transhuman coin and buy and sell goods and services. So our communities have written books like Dr. Jose has done on the death of death, and we'll be listing his book on the e-commerce store as well to sell in transhuman coin. And we're working with the likes of IoTex to do IoT, machine fi, so that you can do things like move to earn. There's also an Africa Rare virtual space that we've been working with. So Bose was one of the lead developers here, and he can speak a little bit about that at the end, which basically hosted the Abundance 360 event, which is for executives all around the world, and to learn about things like longevity, AI. I think Emad from Stability AI was there, and Dr. David Sinclair, who wrote Lifespan, was also there. And we funded crowdfunding platforms like Lifespan.io, which is also funded some of these videos around end aging, cure aging. There's also a YouTube channel called Life Noggins if you want to have some sort of easy way to understand some of these concepts. Also funded this autonomous electric wheelchair company called Abby by GoGo Tech. And this is actually how we can democratize wheelchairs all around the world. There's 500,000 wheelchairs unmet globally. So this is a way we actually accelerate that adoption, especially in emerging markets. And finally, we also got FOXG1. It's a particular genetic disorder that happens to kids that have brain disorders. So we're actually trying to fund and raise awareness about how we can find a cure together for the FOXG1 through the FOXG1 Research Foundation in Australia. It's a bit of a video, but it's our team. And yeah, I'll hand it across to Jonathan. All right, so yeah. Yeah, that comes all right. Get me here. Wrap up those in.
All right. Hello. I'm a really sexy stuff one is a risk but I'm very interested in longevity. And one part of longevity is trying to figure out the ways we can look at quantified self. So I've started with a few other people a project, and actually we didn't have a name for it, so I just made it. But, so I call it Project Erdonis. Erdonis is where. Does anyone know the? No. Good. That's where Planet Vulcan is. So you know, Planet Vulcan is live long and prosper. So there's.
Yeah.
That's the. There's some very easy things we've got out here to measure ourselves. And so when I'm talking about like a quantified self, I think a lot of us know what quantified self means. It's just basically measuring anything and everything we can about ourselves in order to live our best lives. And sometimes we probably go a little too far in that, and just got to keep that measured. But one of the there's a lot of things you can do. Right? Everybody's got their phones. You can use Apple Health. You can use those kind of things. You can track your steps. You can use the old school way of staying on a scale, checking your weight every day, and that gives you indicators of how you're actually doing. One of the things that I've started doing recently that's is actually a big difference is getting what's called a DEXA scan. Can I raise your hands? Who knows what a DEXA scan is? Who's gotten a DEXA scan before? Two. Okay. Well, basically a DEXA scan, it's a very simple scan, and it's actually quite inexpensive as well. I mean, you can, there's a place probably 3 blocks from here that does them. It costs about, you get a deal, I think 2 DEXA scans for $150. So you get about $75 each. And really what a DEXA scan is it's a very, it's a dual energy, but it's a very low, it's an X-ray, and the X-ray basically you lay there, and the machine goes over you a few times, and what it's doing is it's measuring. It measures your bone density, and it measures your how much muscle you have, and then it also measures how much fat you have as well, and it measures some parts of you that you don't really know that much about, which is like your visceral fat, which is like inside your organs, how much fat you have in there. And what I found was interesting is I've been working with a personal trainer for a couple of years, and I thought this sounds he'd been encouraging me to get one, and I thought, well, that'll be okay. I wasn't thinking that much about it, but then I actually went and got it, and when I got it, it was quite. Quite vulnerable when I looked at it because the things you see about yourself, and I see like so this is mine. Hope you don't want me sharing. Is that all right? Everybody's okay with that? So this is kind of how it looks, and you see the parts of you, and you can see the red, the muscle mass you have, and you can see the bone density, and you can see how much fat is there as well, which is not nice. But there's some great things though you can see as well. Is you can look at your bones, and you can get measurements of your bones, and you can see how your bone density is now, and then if you get periodic measurements, you can see how you were. So this is showing my bone density from 4 years ago, where it is now, and luckily my bone density stayed about the same. So that's a really good thing. And luckily it's probably just because I've been lifting weights with a trainer doing things like that. My muscle mass has gone up by a couple of kilos, so that's really good too. But it also showed me where I was doing poorly, like with fat in the wrong spots, and so it really helped me to see things I needed to change immediately. And it's amazing how just getting this information helps the person to change. So I now see a personal trainer after doing this about 3 times a week. I've actually put a lot of time and effort into it, despite me providing beer pizza for you all. I do watch what I eat pretty closely, but this is a very simple scan. Anybody can get it, but it's something that's actually not that high tech of a scan, but it's something that can actually make a big difference in people's lives, and that you can measure it. And I'm doing now. I've committed to about 6 months. So that's the DEXA scan. So you measure muscle. You measure how much fat you have, and you measure your bone density, which as you grow older, all 3 of those are very important and can really tell you where you're going, and it can give you information to make changes in your life.
Yes.
Hey, what? Any question?
At my gym, they have a similar machine.
Yeah, probably.
Yeah, this is like that.
Okay.
Right? It measures this.
Okay.
I don't know if you know that's more or less accurate.
I've got no idea, but you might know.
This is the gold standard.
What's it?
This is the gold standard.
The gold standard. Okay.
You said you went to one like just nearby.
Yeah.
Was that which one did you go to?
So I went to, it's called Measure Up. It's over on Pitt Street, near Martin Place.
Okay.
And it's you book it in. You go there. It's very it's not like going to see a doctor. It probably should be more like going to see a doctor because it feels like you get a lot of analysis.
So you don't need a referral.
No, you can do it, and I think if people do have some osteoporosis that can you can get some Medicare referral.
What's it supposed to go with?
I know it uses an X-ray, but that's as far as I know. That's as far as I know.
What's your vision for the future of what we measure and how we do it?
Oh, well, I guess what I'd like to see is I'd like to see, it's more of my vision of how you meet with the doctor, sort of thing. My vision is that I go sit down with the GP, and the GP says, Jonathan, nice to see you. Pulls up information all about me and my life and how I've been living my life, and has a huge amount of information and can give me something very specific to me, not based, and because every time, if I go see a doctor, the doctor, maybe I go to the wrong doctors, but the doctor, it's as though they see me for the first time. And it's as though they look at me and the first thing they say is, "Oh, it looks like you probably need to watch your diet a little bit." And then they check some blood work, and they can, the closest thing they've got right now is they can look at blood work now compared to when it was before. And that's really the main analysis that they have for me, and that's the main analysis that probably I have for myself, besides looking at my weight and besides looking at those things. But it's more that I'd be able to actually make a lot of decisions and have a lot of measurements, and I know what I want to look like, what I want to be, and I can see myself, and I can have a very clear path to get to that place. That's probably the main thing. Right, a clear path to which road. Yes.
Looking back at that question, how do you see?
Yeah. Probably okay. So right now, I mean, the main wearable I use, it's by some of a lot of things just to have my phone. So I've got my phone, and it measures my steps. And the other thing I use it for is to measure my sleep. So those are like the two things I'm watching really closely. But what I'd love to see more of, and which I know is not that hard for me to do, which is probably my next step, is really measure my heart. Really measure, find ways to measure my stress level, keep my stress level way down, so that I can operate much better. And I think probably taking the technology and that all the different wearables that are used now, they can be put into some real analytics to give me real information to say, you know what, you're doing great, John, you're doing really great in these spaces. If you did A, B, and C, you could be, these are simple things. Your life could be considerably better. You got a massive impact. Well, I've tried ChatGPT. It's interesting. It's interesting. I've tried asking ChatGPT about my health and put together a health plan. And I see the answers, and maybe it's just me, but I don't trust it 100%. Because I think I might know more than you, which is probably, but that's just my thought, because I've now been working with this body for a period of time, and I've seen what's helped me grow to a certain level. I mean, I'd love to see. So I'm really debating. I'd love to see something that could tell me where I'm at at a point in time, the number of reps I should do and what I should do next. I've done bench press. I've done it at a certain weight. I'd love to know, you know what, where you're at now. If you really want the maximum potential for a muscle growth, you should push for 8 to 10 reps right here, or you should do like a pyramid up or something. I'd love that information to come to me. Just to be there. Oh yeah, no, that's next level. Yeah, I think it's great. Has anyone in here had the full body MRI powered by AI? Yeah. Benefits? Did you find benefits, or was it just?
Well, I don't think
Okay. Yeah. But did you find some benefits from it?
Yeah, I got a 300-page private questionnaire report. It's all different on
Good on me.
They actually get the use cheaper than you go against towards the test and to be able to identify those
Trends, yeah, trends.
Yes. Yes, and the evidence was what we got into, but I'm actually kidney treatments, so.
Well, thank you. Happy to answer any more questions afterward. But, this is just my own personal experience.
Yeah. Oh, that's
All right, grab our seats again. Have you had a bathroom break or had a chance to have a chat? So what you're seeing on the screen now is actually the new human augmentation lab. So this is run by Aria, a company that does wearable devices to help the people that have vision impairments. So basically like an echolocation, like Batman tech, using audio to create a 3D environment for the blind. And because they're so hypersensitive to audio, they're able to create sort of a visual sort of image of their surroundings through echolocation. What they've done is actually taken out UTS Building 5 over at 1 Key Street in Haymarket, and they're dedicating the space to help incubate startups that are building in human augmentation. So if you have an idea around how do you help people become super smart, live super long, super well, things around brain-computer interfaces, please let us know, and we're actually going to be starting to have the incubator discussions now. So please feel free to reach out. And also UTS, USID, and also the organizations for disabilities getting involved. There's also a Futures Conference happening next week on the Monday and Tuesday at the ICC. Elise will be speaking representing Transhumanism Australia. Some tickets if you guys need as well. We have some codes available to share for students and others. And also in Canberra, there's actually next Friday, they're running a block event at Capital Blockchain. So this is really educating not only the people in government around blockchain, but also the startups that are building in that space. And so, with that, I think that is all. We got Bo here, ready to plug in. Bo Williams, one of the OG transhumanists from about almost 8 years ago as well. He's been building out the space. He's currently a product manager at Atlassian. And he's actually been helping to build out Africa Red, the metaverse environment. We're showcasing some of that today. Round of applause for Bo. You don't need a lapel or anything like that. No. You get
Yeah. All right, everyone. How are we? Good?
Yeah. You need some audio.
I've had a
jack here.
I've had a crazy day. My hands are all messed up.
You need a seat. Grab a seat here for the legs.
Building up bikes and doing mechanic work. Funny enough, not pure work. So usually my hands hurt from working on my computer. Today it's been silly trying to shove the wheel, tire off the wheel. It's just a lot of work. Cranky tire. Anyways, anyone knows bikes, I know how to get a motorbike tire on a hub is a pain in the ass on a best day. You need a lot of baby power. So here is we're going to start with something fun. I'm actually going to join Mick Mann, who's the founder of Africa Red, in the Africa Red metaverse. So I'm just going to quickly get to our experience. So we recently just decided we're not going to use Zoom anymore. We don't have a reason to. And so essentially, I should have had the link prepared. I'm really sorry, guys. I'm just going to go to our deck meeting. Should be this one that I sent in. See? So, all right. Let's join our metaverse. So I'm going to join with my profile, my Africa Red profile. And we're going to enter. And this is how we do our meetings these days. So it's pretty cool. The fact that we don't need to use Zoom and we meet in our own metaverse. So that's not good. Maybe it says it's in the middle. I clicked the wrong link. Sorry, guys. Give me a second. Fourth, right? Should have maybe. I was not prepared to do this. So I just sort of sprung this on Mick and tried this. So we'll just try a different meeting link. Okay, that's good. I'm just going to join my other room. This is literally the first time I've ever had this problem, which is pretty typical. So I'll try joining the other room. I was hoping it'd be waiting in the room for us.
Nick's over in Cyprus at the moment, right?
Yeah. Okay, I'll just ask him to join the other room real quick. Give me 1 second. Sorry guys about that. It's a bit awkward.
Yeah, so
I just got to quickly send it a link.
yeah. The Mick actually took us on a tour of the space adventure the other day. And so we're people all around the world learning about the singularity, and so this whole Singularity University globally, have an Abundance 360 summit, and really thinking about the future of AI, future longevity. And because it was all done in San Francisco in person, there's a whole bunch of people that didn't get to access the tech and the content. So what better way to make that more accessible? It's actually using the metaverse and actually having that available to replay again and again. And it's sort of the platform that we've been looking to build out. So Transhuman Coin will have a dedicated space for our future events as well. Those that can't join, like Google Meets, is always really hard to try to get a hybrid environment on. And as we quantify more and more of ourselves and digitize that, creating these digital avatars that represent more and more about us, that immersive environment is actually how to make this whole super well-being and accessibility around the world. Yeah, things like Apple Vision Pros might have seen as well. That's going to be taking that to the next level. Obviously, the devices aren't as accessible, but we'll get to the point, just like with smartphones, that you can bring down cost curves. We'll have some of those here.
Okay, well, Mick should be joining in a minute. But the really interesting thing about the metaverse is that when there's no one there, it's really boring. And to be honest, this isn't a great experience. Now, one of the really cool things about the metaverse as well is that it's not real. And so we don't have the kind of physical constraints that we would in the real world. So this kind of changes up the business dynamics a little bit. What I mean is that, typically you'd have, hey, it's Mick. We are. How you going, Mick? Yeah, that's fun.
That's better. Thanks, Nick.
Yeah, cool. And I can share my camera. Here we are. How you going? Nice one. How you doing, mate?
Just mute yourself and mute once, because I think you've got an echo going
How's that?
through the microphones or something.
Yeah, it's from the microphones. You won't be able to hear me now.
And I should unmute now.
Now, Mick's in the co-working space as well, so it's pretty loud. But this was just a quick demonstration of how we like to meet. This is how we conduct our development meetings. And I thought it'd be fun to do a quick live demo for that. So starting out with the links. So yeah, basically the metaverse, right? As I was saying before, the metaverse on your own is a bit lonely. And one of the things that we are working towards at the moment, we brand ourselves as sort of mixed reality and virtual reality. So in the future, we could move into AR as well. Again, like the core of like the Africa Rare metaverse is that we are trying to connect people together, just like we are here. You can meet in a virtual space. We have developers from around the world. They really enjoy meeting in the virtual space. It's a bit more personable than just being on Zoom. And so the future of Africa Rare, as it stands right now, we're working on a few things. But as I was saying before with businesses, so typically buying commercial real estate is pretty expensive. I mean, just real estate's expensive, right? And so we have a metaverse land that we sell, and we are partnered with quite a number of businesses now. And I just wanted to show just a quick little demonstration of a map. So, goddamn, you don't want to know my life. I've got too much going on constantly. Here's our little metaverse map with some of the businesses that we've partnered with so far. So they own a bit of virtual land. We work with designers and the businesses to build custom metaverse experiences. In the future, they'll be able to transact in these virtual experiences. Essentially, they could have any kind of store. You could sell your art. You could sell, just virtual experiences to, like, for example, we worked with a company like MTN. We did a virtual golf challenge. They could come and play virtual golf, and the winners would get a little prize at the end and tickets to an event, which is pretty cool. So there's a lot we can do with the metaverse. But the thing that gets me really excited is the idea of having a virtual storefront. So recently, for example, we partnered with an artist called Connor McCready, who, funnily enough, he has his own blue. He's actually got his own color. One man, one color. It's called McCready Blue. Who would have thought? Now, we sold a art piece at Art Basel for about $750,000. It was a fractionalized NFT artwork, and we donated half of it to charity, to Drops of Life in Africa. And that money will be going towards saving the lives of children by providing them with fresh water, as we can see here. So these are some of the really exciting things for me personally. We're getting more into the business side of stuff. So with the virtual real estate that we're building in the metaverse, one of the really cool things that you're not limited in the virtual world is that, like, if you have a commercial real estate storefront, basically the problem is that, it's really expensive, and you're not going to have 1,000 stores with 1,000 different looks, with 1,000 different customized virtual agents for 1,000 different products. What we're talking about is, like, you can essentially change the way that you sell your products. You can change the way that you connect with your customers. You could have, let's say you're a company that sells in 5 different verticals. You can have 5 different customized virtual metaverse experiences within Africa Rare to serve each vertical, basically. You could have, if you sold 1,000 products, you could have 1,000 custom stores with the 1,000 custom agents that are the experts on each one of those 1,000 products. That's like a whole store for just one product. Now, you wouldn't do that in the real world because that'd be very expensive and probably not viable. But these are the kinds of things that we unlock in the metaverse. And it's really exciting to see that we are actually working towards building this. So we've done quite a few cool things. But the next frontier for us, as I said, it's a bit lonely in the metaverse sometimes. And so that's why we are currently building virtual agents for the metaverse. And so the owners of the Africa Rare land, the businesses that we partner with will be able to create their virtual storefronts, virtual experiences, virtual whatever they want, with our designers that design the land with them. And we'll be able to place virtual agents in that land. So basically, you'll be able to, let's say you want to sell cosmetics, you can come to Africa Rare, you can create virtual land partnering with us. We have a variety of plots, for example, like large plots, small plots, big ones. So you could pick a one by one if you wanted. They go for about $250 US right now. But the cool thing is that soon you'll be able to get a virtual agent that will be able to man your store 24/7. And it'll be a fraction of the cost of manning a real store with a real person. And it'll be accessible globally in 24/7, which is pretty cool. Something you can't do with traditional commercial real estate in the real world. So that's a little bit about the Africa Rare metaverse. Overall, we think that virtual agents and virtual experiences pave the way towards like a whole new avenue of like sort of commercial ventures. And the hub for us is the Africa Rare metaverse. We love working with artists, charities, banks, businesses, telcos, NFT projects, what have you, to create virtual experiences and do fun stuff in the metaverse. So that's a bit about Africa Rare. Thank you everyone for listening. I know it was a bit of a messy stuff with the links. I wasn't prepared. I've had a crazy day. This was fun. Thank you.
Any questions for Bo? Yeah. It says, how's it? Any questions for Bo and the Africa Rare metaverse? Yeah, we're good. Okay. Oh, one question.
Yeah, actually looking at brands like Nike, they've even got patents in this area. So they patented years ago. It sounds like a long time ago. It was like only a year or two ago, but they've been patenting many things to kind of bridge that gap between the physical and the metaverse. We've got companies in Australia, big companies like Meetup, that are building a lot of great stuff in that space with virtual gaming. Which again, if you know about gaming, that goes into the franchise, into the real world. So you can imagine going to a store and buying a virtual figurine and then taking that into your metaverse game on a Mutable or whichever platform. So yeah, I definitely think that bridging of the physical and the virtual will sort of happen over time.
Got Elise here as well, Director of Metaverse at KPMG. Ask more about the digital stuff.
How committed is it given it's shifted to AI? I mean, as soon as they shifted to AI, the stock price recovered to 280, where it metaverse dropped it to 90.
Yeah.
So, I mean, with your project, is it transferable to the Victorian land?
Yeah, I mean, look, the interesting thing is like when your business is a public company, you don't really have a choice anymore. There's a reason why Elon Musk is joking about taking all his companies private, and it's totally understandable because that's like written in the law. I mean, you can't have your stock price go down and then you just go, I don't care because it's my company. He doesn't have a choice. He has to do what he needs to do, and if the market is trending towards in one direction, he has to do that. It doesn't even matter about any of his conviction, what he believes in. It's just whatever the market's trending.
And when Apple launched Vision Pro, they give it marketing. I think it's like a computer.
Spatial compute.
Yes, yeah. So Apple's a very interesting company. That one, I really like their approach. I think they're really trying to take it beyond just the hype and just words and stuff, and make it like user friendly. Very good at that side of things, I think.
Make it something you want to wear.
Yeah.
I guess for the thought, I'm just thinking to myself, there's a lot of companies how we make dashboards these days now. And everyone is that these things, like it looks like happening is a shift or more good. Right. And so I guess like how do you see that unfolding? How do you see like what type of things that today dashboards and things that are going to be replaced in these spatial interfaces, so intuitive like
Yeah, so that's actually something I'm pretty excited about, essentially with our here's frozen. Yeah, that's something I've been really excited about with the virtual agents for the storefronts. So, I mean, we could design stores. We can have designers design stores where you've got like a physical space and you can walk around and you can touch the objects, and that's really cool. And maybe like, for example, in our earlier iterations, we'd actually physically walk over to something you could buy, and then you'd be able to buy it. I think as well, like just being able to walk into a land, immediately as you enter the experience, there's like an agent to greet you. You can speak, natural language with it. Hey, what's this store about? What are they doing? What are they selling? And then in the future, enabling potentially like an actual transaction on chain with the virtual agent would be super exciting.
We're able to partner with TouchStage, Xbox.
Yeah. It's a good question. I mean, I'd like to partner with PlayStation, Microsoft, and Facebook. That'd be great. If they give me a call, I'll say yes. But no, I mean, our sort of focus for now has been around like the social side of like connecting people, providing experiences, but potentially in the future we could look to break into sort of the gaming scene. And I totally understand like gaming is worth more than movies now, which is crazy. So yeah, like virtual characters, like both Holden, Tom Cruise.
Last question, yeah. Last question. Yeah. Sure. Last question. Yeah.
So, about the old 30 yeah, like the metaverse, isn't that, like, does anyone just not see it as colours?
Yeah.
I said, like, I'm talking 2003, the second line of developed in the late 90s. Crashed the lot. But the same thing is happening, right? All the big companies and corporates moving, they put storefronts, they advertise, they put space. Like,
Yeah, it hasn't had
maybe
its
we're ready this time.
yeah, it hasn't had its moment yet. Yeah, it hasn't had a chat GPT moment. But I think hopefully like what Apple's doing is mainstream. That AI has gone through those hype cycles in the past. You know, they thought they could solve intelligence like back in the 80s.
There's a saying, you don't hire AI researchers who've been doing it for more than 10 years now.
Yeah.
Or even 5 years.
So
right?
Web3,
They just, they don't know what they're doing because it's the new thing.
But we're seeing now that the underlying infrastructure is starting to come together. So whether it's the spatial computing side or the blockchain layer side, it's all starting to become, you know, ready at that near the curve. So as soon as that sort of, you know, mainstream adoption use case comes out, could be augmented reality, what we're seeing, eventually what Apple's going to be doing. But, yeah, and eventually we might need some brain-computer interfaces. So I don't want to keep Dr. Avinash waiting. Thanks a lot, Bo. Yeah, feel free to take another bathroom break while we set up. You know, if you want to find out more about what we're doing with Africa Rare and Transhuman Coin, we'll have some updates towards the end of the year thanks to Mick and the team that we're building out our brain space. Cool. All right. Here. Skip recording there. That should be perfect. Yeah, got some water in it. All right. Thanks for making it, Dr. Avinash. Round of applause right now.
Well, hello everyone. Believe me or not, I started at 5 p.m. from UTS and I did around 7, 2 hours to come here. Just so many things happen in the way and I ended up very slow that I'm here. Well, myself, Avinash Kumar Singh, yeah, I opened the wrong stuff, sorry.
Hands up if you're from UTS or went to the BCR workshop last Monday. Was it 2 months ago? Yeah, excellent. Yeah, so Avinash was running a BCI workshop, brain computer interface workshop there, for everyone to really understand what we're actually dealing with now. They're working again, we talked about non-invasive brain computer interfaces, but it was just amazing that you can actually decipher the data coming through your brain right now and actually find use cases. So yeah,
Yes.
we can.
Yes. So I work at UTS, of course, like I did mention. I'm a lecturer there. And potentially UTS is maybe one of the largest research locations where we do a lot of BCR. Doesn't matter whether industry or defense, both. So we're doing a lot of plenty stuff. So you're all welcome to join. And what I do specifically, I call it neural interface. I have some survey and stuff, and I'm going to skip that. Late. My philosophy behind BCI is limited to these 3 circles you can see. What I'm doing BCI is for replace, restore, or enhance. These are the 3 things. And maybe that's the reason why transhumanism comes in, which is philosophically to enhance a human being. And this is a very quick summary what you see here in the picture I did so far. And what I'm going to do in this presentation, I'm going to show you what I have done so far, what's happening right now with me and all the students I have in the lab, and what might the future look like. Very brief touch on that. and happy to talk about that. Well, starting with this image, I really like this one. It's very much similar to Da Vinci. I don't know what we call that, but this is a cybernetic version of that. Taken from book cover of Stephen et al., published a couple of years ago. You can see there's a Boston Dynamics talk there, which is for someone sitting with that metaverse, which you're talking about a couple of minutes ago. And all the brain computer interface things are passing by this. And I call this particular work, which I'm doing right now, is neuroadaptive BCI or neuroadaptive interface as well. But there's so many terminology as well, so that's another thing I want to clarify. Brain-computer interface, bit outdated term. Neurotech is more popular among everyone, and there's a neural interface as well. People call it brain, mind control, and all sort of words are out there. What I do in neuroadaptive interfaces, the way it's described, I'm trying to adapt based on the brain. Now, think of a scenario. Maybe you have seen a movie called Bender's Match on Netflix. Have you ever heard it? Right? It's like a gaming movie, and this is the kind of experiment by Netflix, where movie have multiple endings, multiple scenarios, and movie will pop up with you a question. What do you want to do? This and that. You can select some answer, and movie adapt according to that answer you select. Now think about the scenario. It's more personalized, using your brain itself. You're watching a movie, and we know based on your data that what kind of information and scene excite you. And movie adapt accordingly. It becomes very personalized version of a movie watching experience. Same can goes to reading, same goes to environment, and same goes to literally anything you're doing, including your car and human agent feeling, what I call, where agent could be a technology and human could be the one who's using BCI. And these two can work together in a way that the machine is always personalized and adapted towards you. So this is what I do here. Some of the example I want to show here. This is a very simple example of BCI where we're controlling a drone. Let's see if I can turn faster in this week. I'm going to show you how then signal capture. So this is a very simple example taken by a couple of students, undergraduate students, where they controlling this single tiny drone using brain computer interface, this signal in real time. So that's another thing we do, emphasize a lot. Whatever we do is very translational in nature. It has to be real time. If it's not real time, it's become very lab constrained experiment. This is another example on the top where maybe some of you have seen my presentation, and you may have seen this video where we control our robotic arm with brain signal. It's very simple 5 sort of command. This is a very old one, but I still like this video, so I want to show you. I'm not gonna have it. So this robotic arm you can see here is essentially feeding this participant who's wearing a headset, you can see, which is a wireless, and just using 2 sensors on the back of the head and translating this all information to a PC, which is sitting somewhere down there, and the PC converting into a command and sending it to the robot. This robot arm is called, I think, Kiko, which is very precise for human interaction. And there's a small food tray with a food built in, and this robotic arm essentially feeding this person. We call it eating assistant system. But essentially we're demonstrating a concept where a BCI can be used. This is again from the lab. The BCI can be used to help a disabled person, which is again one of the very fundamental goals of BCI, I think. If you read, that's where the story comes in. You want to help a disabled, or you want to help someone who has some type of paralysis. They want to communicate, but they can't. And that's where the BCI bypass all the muscles or memory you have, and just take the signal from your brain and communicate with that technology. This is another example, which is more around BCI neuroadaptation. So we did this experiment before I start. We did this experiment for air traffic controller. So this dot essentially representing a plane flying around, and an ATC controller sitting in a tower has to literally watch from the window what's going on. In addition to a dashboard on there in front of him or her, and ATC controller. And when they do this kind of task, there's a very little chance they should do a mistake. Very little chance. I mean, one mistake may end up with a fatal accident, right? So there's no chance, no margin error allowed. And that's the reason they are very high workload. Actually, one ATC controller actually just work 2 or 3 days a week, just because it's too high workloaded job. They can't continue for 4 weeks. And very few people actually interested in this job, of course, because it's too workloaded job. So there's a very few people also involved in that job. What we try to demonstrate here that maybe a PCI technology or neural interface can adapt. When I say adapt, AI, which is machine learning behind the scene, can take over big part of the task on those occasions where the ATC controller can't take care of the job with high performance or can't make the decision he has to do. So I'll give you a task. What you have to do, you have to follow, I think it's a blue dot. Let's see. Yeah. You just have to follow the blue dot, but it changed color to black. If I am black. What I'm doing on the right side is measuring your cognitive load. It's a small meter. Essentially, you are very okay. I mean, this is not real time, but the user who was following this, so you can be asking him where is the actual dot is located. Now let's look at a bit complicated scenario where you have 3 dots. Try to follow it again. See how it feels like. Some of you may have lost it already. Maybe some of you are still tracking it very well. This is the job of ATC every day. They have to still simplified version. You got any? Any of them are correct? Yeah. Now look at the big complicated version. It's more complicated version. Where we ask you to track 4 dots. Now things become very complicated. That a normal human being, unless he has superpower, can't really track them all at the same time. It's going around. This is, although it's not really a plane which goes all around the sky, just on a flat 2D screen. It's still so difficult that when we ask the user to perform, their mental report is going out of. Yeah, it's impossible almost. Now what we did, with the help of AI, we already identified those dots, adapted, because this AI detected the mental workload is super high, and we try to give this assistant that they don't have to detect, but AI can do some job. Now, there's always a trust issue with AI, so we don't want to give all the job to AI, but want to keep the human involved and only supporting this user when AI detect the cognitive performance or the ability to make a proper decision is not so good, which is available. This is another great example of neuroadaptive PCR. There's a few other things I do with neuroadaptive PCR where we have a robot which is we call PHRC. PHRC stands for Physical Human Robot Interaction. So this robot is not just doing their job, but essentially you are controlling the robot. It's a semi-autonomous robot. Robot detect what you want and simplify job for you. So you're still holding the robot, you're still in control, but robot take most of the pressure, most of the power, most of the complexity of the task itself. Now this robot, for example, if I ask one of you to go and try to take over this robot, you may have to train yourself before you know how to operate that, right? Now what if I say, use your brain signal, okay, neuroadaptation. Put this in your head, and this robot, because learning from your experience, kind of synchronize together. Machine synchronizing you, and you are learning robot anyway over the time. So the overall time of learning can shorten. So that's where another application we did in the lab. Again, the broader term in research word for us is called human agent teaming or human agent synchronization. But that's another version of this. So this is something we already did and something is still going on in this space. Now, this is something new. And of course, you know why, because lots of famous work happening in generative AI, right? So many nice model has been out there, either language model or diffusion or image model by all sorts of companies, OpenAI, Meta, or Google, all these companies are doing. So we just started playing around with, can we use, one thing I haven't mentioned, I think, do you see I'm using the sensor on the top of the head, right? It's called non-invasive sensor. You're not using implant, you're not using fancy, very complicated fMRI, simply EEG, which you can go and buy with a couple of $100. Very portable and very cost effective, I should say. And that's where we started playing around. Can we also use EEG to do reconstruction? You may have seen this work published like 10 years ago, where a scientist in Japan put the participant or user into a fMRI machine, scan the brain signal, and reconstructed the whole continuous form as a movie. That's just from brain signal. This is what person watched. This is 10 years ago, when generative model is not a big thing either. But still they were able to achieve this. Why? Because fMRI can capture pretty detailed information from the brain. So it's possible. Now, again, I'm going to go with the EEG, but before I go, this is another one, which also happened a couple of years ago, where reconstruction happened about the speech, where user is just thinking about what they have to speak. It's from University of California 2 years ago from Dr. Edward Chen, which is very popular in speak. But you can see this is an implant. You don't want to have this and want to have brain computer interface, right? I don't think brain, this portability is not the big thing. We think, can we try the same concept with EEG? And if you are active in research work, some of you are not sure, you may have seen there's a few research work has been started pop up here and there, which is talking about EEG-based reconstruction. So we also thought to play. I'm going to skip this slide because this is the work which happened 10 years ago. This is the professor, and this is essentially a student who did this again with more high level of skip. We tried, can we also do with the EEG? We use a simple small set of the data set. More importantly, very few sensors, was non-invasive. Second thing, we want to make it real time, which I haven't seen any work which has been done with EEG the real time. With a small set of data set, this is still ongoing work, by the way. Like I mentioned, this is just something we were able to reconstruct quite closely. So these are the things shown to the user for a few fraction of second and ask them to visualize. And this is the constructed from the brain signal, just EEG. So very encouraging result, and of course there could be lots of applications. Yes. Sorry? No. Oh, compared to them, well, of course they are still a lot better. No doubt in that. But once we have, so what we are something here, we are currently designing an experiment to collect a large quantity of data to reconstruct that. Yes.
So like EEG is in most researchers.
Well, we do not face too much problem in terms of the quality of signal, so it's okay. But of course, you can have different material that give you better what we call signal to noise ratio. And like I said, we do translation research, so we don't do it in the lab. We just let people go outside, walk on the road. If you go around, you just find complicated version or simplified version walking around and performing experiment. So it's all from here. But of course, this is not this one, because we want to test the approach first, which working pretty well, and also real time. Now we want to go ahead and try to see a bit more over here. Yes.
So, they use the images from the first. What happens to show the image that wasn't part of a new category?
So in this specific this one, that doesn't perform so well.
Yeah.
So they do not learn those features we were expecting. That's why we want to expand it a bit more. So currently what you can see, scooter looks pretty close, but it has to be car also not too bad. But you see Apple just a bit messed up. Just blurred.
Well, I mean, it's basically that what you capture from EEG is the fact that it's one of the categories. Then as soon as you feed that, any generic flow, or the can generate backwards. So
Yeah.
I wonder where this balance you can actually read the brain and percentage of the brain for the instructions.
Oh, right.
Giant approaches.
Oh, well, of course. In this case, generative model is heavily dependent on those reference. That's why I'm saying power of generative model is really strong that it can just give a little clue where it can generate. But like you can see, the scooter shown to the user is orientation is different, the one generated. So obviously there's a big disconnect at this moment.
Is it the image that they have a relationship or for example, I had okay, I can see this image, but I need to write it up. I know this. Is there any research to say I see this, but I'm using this is not asking.
Actually, exactly that's what we did. So this reference image is just shown for a very short period of time, and we just let them. They're looking for Nokia phone of this kind, but this relation is a Nokia phone or something they came across. So there's a difference. So you can see what in the end this model will still able to extract those important features of the mobile phone structure. Regardless of actual phone they have shown on the map. They don't have to, I mean, they are not trying to replicate exactly shown image to the participant. We just want to generate the image they think is similar. And we ask these users, is there something you visualize? But they can't really construct exactly same. Again, the model doesn't construct exactly same what they visualize, but it matched with their thoughts.
The sort of that is, I think, work also with
very early work. This is still early. That's why we want to explore lots of potential direction. This is the experimenting, and it seems like there's a possibility, which is very, very strong. Like you can say, to be published, it is still ongoing work. And what we're trying to collect more data, then there's a different kind of people with some mental disorder, or even people who are blind. I don't know how they visualize things, right? Maybe they don't visualize, they hear things. So many categories, so many possibilities are there with this approach, and that's what we're going to try.
These English language speakers,
All of them, yes.
have you like interested in
Like I said, this is still open sky at this moment. So these are English speakers. They all know English. At least that's one of the language, not the first language necessarily, but seems like so far.
Yes. Are you generating these by associating EEG recorded from the database, or is that yes?
That's right. So you have to train, right? And training involved to minimizing this difference between what the generated EEG features are versus what we get represented. So that data is training data, and this one is generated from testing basis.
these knowledge graphs?
Not in this case. This is very simple approach where we can also try or encoder if we ever tried this. This is simply what happens.
So use people's visualization to generate techniques. You get a sense that some people are better at visualizing than others.
Yeah, we do. So that's where we divide our strategy, how to do that. For example, we don't just ask them to visualize. We ask them to think about you and using it. For example, when you say, okay, visualize a phone, maybe they just find one, not necessarily even visualize it. But you ask them, can you visualize your phone, which you have to, I mean, just put pretty much store behind that. Visualize a phone which you have using last 2 years and call it the mom, for instance. Then this image they visualize becomes stronger. So that's a strategy we use in this case. That's it.
I would love to see this used to visualize the dreams. Do you know if there's a technique the energy? Yeah, like it's a visual vortex.
Yeah, I think so. Like I said, we have lots of hope with this work. And because of portability and ease of access to let lots of people try, we're going to try so many different seconds. So this is ongoing work, and hopefully in a couple of weeks, what we did here will be published and potentially other experiment in the next few months, because this field is really growing so fast. And again, if you look at the Google, go and search about this, you'll find there's a few other people doing this work. And machine learning is very competitive. And then you have these big companies.
Right, it's along those lines, like, is there an open data set for all of this? Like, it's fun to mess around with like 10,000 people all have different scan.
Unfortunately, not 10,000, but there are data set which is about 20, 24 people. You can use and play.
Could we get like a consumer headset and do it ourselves? Like, just get everyone in the room. For an Apple type
I wish that doesn't work.
Set up a big push. With the starter set. And then they're able to and then even put that up.
Well, we were still working. We came across this data set, like I showed you just previous video, right? And there's actually a lot of similar data set. Interestingly, just I think a week ago, a paper published which talk about that work, where they just extract the data literally from anywhere, which is about fMRI or EEG. Unfortunately, the work I tried to replicate. There's a lot of things I'm missing there. Maybe they haven't published completely, but that's another goal. And in this case, we're using simple auto decoder encoder technique, right? Now you have diffuser method, which kind of can generate method. And then approach of diffusion is very different than encoder method. So that could also add cost. So we are trying to ways. One experiment which we are doing in the lab, but we're also trying to see existing data, not necessarily the data where the image is visualized, but data where the image and the brain are associated in some way. Doesn't matter different experiment. And we also use that in first. Okay, it's an ongoing work. We'll keep you updated.
So they can see if they actually read the images of the sleeping of what content is. So we're looking at privacy issues. So those stuff is already being done. See if the school can expose their things.
Lots of bunch of sleep. They're very happy.
Okay. I'm going to move to another. You asked him? Well, so this is something can convert it to real time, and we were able to do this in real time. The previous work you can see is also real time. And that's why I had one quiz, but I'm going to skip it. But if you like to scan, you can do that. But I'm asking, why do you think BCI still fail to reach your home? You can skip that quiz. Just curious to hear your thoughts. Why BCI is not there? I mean, we talked about the tree, we talked about the control, robots. Yes.
Are you working with digital learning? So all students school. I got different skin. Or I actually have you uses for you as say
no, but recently, I mean, since this beginning of this year, I'm going to close it at think someone mentioned about NVIDIA, how good marketing company they are. And we are doing something, a very special kind of teaching with Apple to very special students within UTS at this moment. And we call it challenge-based learning. And we haven't done a study on that, but based on their behavioral information or very subjective information like a survey and stuff, they were based on challenge-based learning, which is not the case with other mechanism of the study. It's very unique approach. You give with the problem and you try to go from top to down approach, essentially. They were able to perform so well and so encouraged, so inspired. And again, this is something to talk outside. But yeah, it happened. And I think retention mechanism, when you facing a problem and you have to solve the problem, not because you were given exercise, but because it's challenging you intellectually. So it does different things when you learn that.
So you add to that, what problem are you trying to solve? What are your problems?
Well, I'm talking about Apple again. I haven't done any experiment on that, but what we do with this Apple cohort in Sydney is we ask them to think about the problem they interested in solve, brainstorm it, go through a multiple design process and stuff, then come up with what is the unique part they want to solve, and then they start work. So we don't give them a problem. They come up with their problem in a group and then try to converge into a very specific question they want to answer, and then they start working. So that's another thing. So it's a bit of independence. Maybe that's also adds something to that. Well, my question about the previous one, why BCI is still not in the, we don't use that. And yeah.
Yeah. I bought a moose. Yeah, moose too.
What's that?
Moose.
Moose. Yeah,
moose.
Yes. Yes.
Yeah. So I brought it in and I was very excited when I got it. And I said to someone, hey, try this. And the first thing they said is no. Ooh, right? Because they didn't want their brains read. No, I'm serious, right? And like me, when I saw the first thing, I thought, I want to get one of these because I want to see how I can do stuff, right? Yeah. But when I took one to work and I said, hey, look, guys, look what you can do. You can get all these readings and stuff. No, right? I don't want my brain read, right? And I was scared of it, right? And also there's the cost, right? There's the cost.
I was like, Susie, I put like a little map to scan movement. Is PhD and it was quite interesting. One super mitigation, massive problem. Right, it's taking this thing as mission. Anyways, there and I think what you're saying is true, but I also think it's such an interesting thing, right? Because it's like there are massive pains that people have to solve by taking an extension of the identity. And so I feel like the real problem is not necessarily in this space. The real problem more so seems to be the structure of it, it being built in a technical plan.
Yeah, definitely ethics always on the new technology, right? But in addition to that, especially non-invasive PCI, like, it doesn't actually work the way that's supposed to work. I mean, again, Australia may be, again, one of the best countries where you have lots of PCI company as well. Emotil is somewhere from Sydney and Macquarie University, right? There's something called Copymatics that we have run. It's a clinical EEG system. Come from Melbourne. Synchron, of course, everyone knows is very competitive from the US side. They also come from Australia. And there's so many more, which is maybe not that popular, but also originated in Australia. Emotil is a good case where I have said maybe costs you like $300 to $400. You can buy it. They have nice app store. You can play lots of games. Still, it's very much like when you talk about AR, VR, and metaverse as well, right? There's a nice devices out there. They work so well as well, but still you don't try. But and that's the question we asking other day in the lab meeting. But why a VR or AR is not being used same way as we using television for the last 60 years. You can sit in front of television, watch the movies all day, the program all day, without worrying about the eyes and fatigue and all those issues. Same goes to mobile phone. This is also okay, we can do that. But when it comes to AR or VR, we can hear the same thing much more fancy way. It doesn't translate well with the people, right?
The next question is where it's really, and we can see and with this text, of course,
and that's what we want to do. So we also want to reconstruct other things like a text as well, but haven't done that. So, well, one, of course, big reason is the ecosystem. It doesn't well, or maybe Apple is not involved. We can sell very well. Well, BCI is also quite buzz because of marketing reason of some popular people like I guess, or Facebook. And that's, we also trying to do something around that. We have this bulky hardware, which not looks nice and friendly, but it does the job. But when you talk about translation, where it goes to the public like you, doesn't go very well. And that's where we're trying to do, we also trying to touch ecosystem. Although that's not expertise of mine or our lab, but we also touch ecosystem where we're trying to have a bit of hardware part as well. We're miniaturizing in a way that hardware can translate well, and of course, anyone can use it because it's already always population open source. So you can also use and customize. So we are trying to play around with all sort of hardware where you can put everything, including all fancy deep learning models, which need the high processing GPU, into these devices, which they may or may not work very well. But for example, this is a very well-known Raspberry Pi you may came across it. So, and that's a system on chip. That's what we want to see. To put everything, control them together in there, to develop some sort of an operating system approach. You can customize, and if you heard robotic operating system, you may heard, right? Which give you all sort of library and program interface that can let you do lots of programs. And that's what we're trying to do with PCI as well. So you can embed with your existing hardware in a way it's safe and compatible. This is an example come from one of the student work. This is all done in a deep learning model, classifying brain signal in real time again. And what it does is simply take input for the data, process it, and it's currently stream it over the server. Can't access the link if you try, but this is the recorded video where take a lot of time because it's buffering the data. Once it buffers, you start producing the output right away. And this is just an interface I have one, but just trying to show you what's possible with that system as well. And that is what we also do in the lab, try to put together. So translation becomes easier for us. Want to take it further level, search outside the lab. One additional thing we are also trying to do in the lab, which is also ongoing work. We're trying to not make the EEG device more of a spread all over your head, but trying to use what we call hearables. I'm not sure if you heard that. It's becoming a popular thing as well, where you get everything in this small hearable or your pods. All the sensors are here, so you don't need something extra. Same thing can happen with EEG as well. You can measure the signal from the here as well, and that's what we experiment with. And what we're doing, EEG is a one kind of approach. We are looking for more photonics approach where we can use near infrared kind of signal from the ear to measure frequency. This becomes much easier to wear and access and this is another part. What channels? Of course, it doesn't. So, of course, this doesn't quite match with the traditional EEG system setting. And again, what we are doing, we are not doing EEG, we are doing apneias here. This is haven't been done at all so far in the past. And engineers can do a lot more measurement instead of just EEG signal. But this is the EEG. This is the one existing work someone published, I think, in Germany, where the sensor can measure all temporal region of the brain, and can also infer something from this region, which is called motor region, or something called your visual cortex, where you can see things or visualize them. This can infer those information as well. So they have possibility, but maybe not so great as the whole system. But when you customize an application, focus on these sensors, they work. And like I showed you earlier, that speech reconstruction, these sensors are excellent for that because it's all happening in the temporal. So maybe this is something we see coming years. It's actually, besides EEG, there's something like that, the hardware already existing. But we are trying to do something with FDF, because we have some other issues as well. This leads me to kind of very close to last slide, where I'm looking for future, and what we're looking in the future, I just want to highlight. Hardware getting better and better. I mean, including the implant, if we talk about anyone chip from US, Neuralink, US. At the same time, AI is really getting too powerful. Why? Not because you are training the model, because these big companies are training models, leaving it open source. You can infer those trained models and build something on top of it. It's possible to do a lot of things. I just showed you reconstruction, which is a one chest example. But logging or even dream reconstruction would be very amazing to see, right? How it feels like, what you see in the dream. But not just that, linked to that, maybe it's something called law enforcement. You describe someone, a killer's face, was actually driving, doesn't have to be there. Or you just try to visualize your thought, which may and may not look like a known image, but something coming out of the brain. In addition to that, something else like a VCI avatar, or where you can simply control your human 2.0, which is a digital bioengineered version, sitting there in somewhere in metaverse, for instance, or virtual reality, and so many possibilities. Usually the sky is so open in that direction, especially when we come to the VCI. And of course, these might be scary as well. Like in neuroethics, you just mentioned, but people don't want to use it, meaning you're reading their brain signal, right? So we also do something in that space. Especially I do a lot in that space where we're trying to create responsible technology. For that, I work closely with one of the organizations on IEEE Brain. IEEE is a popular organization, and we engineering related work you do. So I lead a group called Work and Employment-Based Neurotech, where we're developing a set of rules and a framework that set a guideline for literally anyone who wants to adopt based on it. Generally, these rules reflect into FDA in US, this is a US organization, and from FDA, of course, go all around the world. Plus, I recently submitted, actually just 2 days ago, there's a United Nations Human Rights Council looking for input about neurotech, what to implement, what to do, because that's again a concern of lots of people. So I'm also quite active in this area. So whenever we create technology, we want to make sure it's safe and not misusing the data, which is a big thing, especially nowadays. And with this brings me to the last slide. Thank you. Thank you for me.
Any last questions for Ravidas?
Mention everyone would have this EEG device as a problem. And they all the time of the same ecosystem, so that is covered. What is for you number one happen?
Silent communication, maybe?
It's not
so what you see now, or every single thing I've shown is one way we see that. You're just reading and doing something. While I'm also looking for 2D VCIs also up there. But not just read, but also write. Of course, EEG can't do that. You need something else to do that. But EEG signal can help to divert or specify the location where to write. And that's where the enhancement, some other kind of enhancement can come in, either it's a memory enhancement or it's other downloading some training material and things like that. I mean, you can.
You do something basic, like body language. I mean, we can sort of see body language, but if you're able to communicate that with your client in a sort of polite kind of way, yeah.
I mean, Parkinson is a disease where you start, your muscle tremor a lot, right? And they get an implant, which is a kind of EEG plus read and write book. What it does, it take the signal every time tremor start as quick as possible and try to suppress that. And suppression happens by writing those information back to the specified location based on the implant, implant base. So this kind of thing already exists, and there's a lots of people using Parkinson implant. Not millions, but thousands of people already. Cochlear implant is another similar story where currently Google is trying to make it hyper-personalized in Sydney, where they want to use the cochlear implant-based information as well, while they're sending the sound and in a way that becomes super personalized, that not just you can listen because you can't hear before, but also maybe there's all sort of other job as well for you based on those all trending model out there. Yeah.
So it's like, let's say they have a dog.
Yeah.
Okay. What are the most interesting questions I guess that I have to ask? I mean, like one example I would think of would be, do people have relative morals or?
Yeah. I mean, yeah.
Sorry, I love this stuff. Wait, this. Let's just say I have a few days. I got maybe $2,000 budget. Can I buy a couple of devices and mess around with this stuff?
Yeah, I think so.
How do I do that?
How to do that?
No, when we go, where do I start?
Well, I think the very first thing you need a hardware. Because you can get lots of software.
Right? Can I buy on Amazon? I get something.
Keyboard, I just mentioned. Right. Let's go with lady first. Yeah, please.
So, similar to the AI involved in the study last 50, right?
Yeah.
They became kind of wild west in the mainstream.
Yeah.
And therefore now we can't really protect and employed. So we're kind of in that stage now with these, we're still pre-mainstream. So do you think they're going to be able to protect it from being bigger or when you go wild west?
It's a complicated question.
You can pretty print this now, right?
Yeah. Obviously, it's hard.
It's hard, and it's hard specifically because you don't know the potential of the still. Same goes to, I mean, ChatGPT is an excellent example. Why? Because it just started somehow in November, December last year. Just been 6 months. It's like what is upside down, especially in education. I'm working in university. I know how trouble we are facing with ChatGPT. The students just populating everything via ChatGPT, and it's not like a copy paste. They can change things, and ChatGPT also can give a different version of answer. It's really difficult to tackle the problem. And the best way, you don't ban it, don't just stop the genie in the bottle, but you let it evolve. And same time, you also evolve. I think maybe that's the best solution.
So you're not even, it's the only trying to privilege in AI side. I mean, that is so long. So I'm just wondering, well, the precursor, it's like how do we do that now?
Yeah, open source and being practical about it, seeing what everyone's able to do. It's the biggest danger of probably locking in some big tech companies where they can actually have control without that visibility, which is unfortunate without the AI. But this is going to be the way to go. But yeah, open sourcing the tech, make it 3D printable, but you don't iterate segmentations around, so you can actually go understand it's not quickly.
Exactly. I mean, more open source technology, more people have access up, so they know what's going on, so more people can find the problem and issues and solve step by step. That's the best way at this moment. But there might be more to see. Yeah. You are.
Yeah. it's doing the same for guys. Definitely understand the applications. The writing aspect. Very like, I would say exactly very well. So there's some time.
Well, my reason, if you ask me why, is not, of course, it's a concern, right? Second concern when you're using a technology. I don't know, this is a human nature where technology too much depend on you. So you have to put on your hair or do something with that. Doesn't go as planned. So as less as interaction possible with you, and you can execute things with technology. Like that's what Apple does, right? Just make a so nice interface that minimize your interaction and do very much like magic, and they are very successful at that. So design problem essentially. For instance, I give you an example where University of Sydney, I think it just happened a few days ago, they published one research work where they can measure using infrared lights your heart rhythm and your all sort of blood pressure and all that from far without touching the body. Think about this implementation on the here. And same implementation with EEG or similar sort of device where you just come into the house, use a scan, and things just start evolving and changing around you, adapting around you. You will like to adapt that because your effort becomes less, right? And because you don't need to put, you don't need to train, you don't need to read the signal or translate into a machine learning device, but it just gets started immediately once you get into the house. Right. Well, there's a deep brain stimulus. Stimulation already exists. Like I said, Parkinson's is a great example, which is already people using it for writing. Neuralink, they have sensor M1G that can read and write code as well. Yeah, there's a TTCS, something called transcranial direct current, which is very ugly version of stimulus, but it also does the job. TTCS. Or you just search for Jeff with the signal. So there's a lot of devices. It's essentially a current sending back, which kind of manipulate by neurons and just something.
The problem with writing is that you know what to write, right? So you have no idea how to work on these pieces. There's not a language. So the whole area, we don't know the code of literally visual area. So there are interesting writing devices in your own area because you know how to stimulate retina or visual area. You produce something in like we have a camera transforms into spikes, but provision to produce huge spikes essentially. And I think that's related. That's like
Exactly. I mean, writing is a lot of writing could be a letter ABC or simply a suppression of the system, which already possible because it's a group of neurons you are suppressing. But exact writing, yes, it's far more. Has been done there. But there's an expert, there's a research where it's possible to switch on and off very simple commands, which is the brain using a photon or optics. But this is very early stage. What you need to do more in that space is a more nano tech to develop a more advanced technology or sensor that is actually writes for individual neuron or group of neurons, which is more that I can say.
I think that's all the time we have for the rest of us. Pretty much covering everyone. We'll have some networking now, and feel free to grab some more drinks. We're not here until I think 8:30 or so before we can get out of here. Again, thanks for coming for a transhumanism event. And as you can see, the tech is moving fast. Probably a single most important tech that we'll have in the coming horizon. And I hope you guys see you guys next time. Yeah.